Okay, so we're just going to proceed now. Yeah, we are going to start. Let's do a mic check really quick. Yeah. Check. Yeah. All right, so that looks like it's working. Camera doesn't look like it's working. For some reason I can't get this camera to work. Whatevers. Let's go and do this. Great. Let's start with question 1. So we have this integral. It's a wonderful integral. Okay, we have an integral of work. Sweet. Five x to the 4 plus 1 over x squared minus 1 dx. So the key here is the degree of the numerator. If I can find a way to write this. The degree of the numerator. A numerator is greater than the degree of the denominator. So that means that we have to, we must divide. Okay. So, let's do the division. We're going to have the divisor, which is x squared minus 1, into the dividend, 5x to the 4th, 0x cubed, 0x squared, 0x plus 1. Okay, x squared into 5x to the 4th, I think that's 5x squares. 5x squared times 5 times x squared is 5x to the 4th. 5x squared times negative 1 is minus 5x squared. Line it, subtract it by changing the signs, and then adding. So now we have 5x squared, bring down plus 1. And then I think we need to multiply by plus 5. That gives me 5x squared minus 5. Switch signs and add it. That's 6. So that's going to give me a remainder of plus 6 over x squared minus 1. That's all the pre-work that you need to do before you can even start on the calculus. So my integral, which was 5x to the 4th plus 1 over x squared minus 1 dx, is equivalent to the integral 5x squared plus 5 plus 6 over x squared minus 1 dx. Okay, we can integrate the first two terms. The first term is 5/3 x cubed. Second term is 5x. And then that last term, we're just going to rewrite it because we have to do something special for that last term. That's what we're going to be working on. So let's see, 6 over x squared minus 1. That's a over x plus 1 plus b over x minus 1. So 6 is equal to x minus 1a plus x plus 1b. I'll say x equals negative 1. That gives me 6 equals negative 2a plus 0b. So a equals negative 3. If x equals 1, then 6 equals 0a plus 2b, so b equals 3. So the integral of 5x squared plus 5 plus 6 over x squared minus 1 dx is equal to 5/3 x cubed plus 5x plus the integral of negative 3 over x plus 1 plus 3 over x minus 1 dx. That's equal to 5/3 x cubed plus 5x. Now this negative 3 becomes constant, and this is the natural log of x plus 1. This 3 also becomes constant, and natural log of x minus 1. And now we can put our plus constants. I think there's one, possibly two simplifications you could make. You could factor out the 3, rearrange the order. Gives you the natural log of x minus 1 minus the natural log of x plus 1 constant. And then you can turn that into a ratio. Now, it's possible to take that 3 and raise it as a power here, but I think that since that won't help us with the absolute values, it's not really necessary. But you should be able to recognize it if it is raised as a power. Adam?
How do we know if the absolute values are necessary?
Even power, even root. Anytime the range is strictly positive, you don't need it. Okay. Question 2 we did in 2 of the classes. Yeah.
For the problem, if you have a degree, if you have equal degrees on the top and the bottom.
You still have to divide.
Okay, and what if it's lower on the top?
Lower on top is perfect. Okay. Let's type that in here. If the degree of the numerator is greater than or equal to degree of the denominator. Then divide. How's that? That make sense? Okay, so let's continue with 2. You want to separate variables. So y prime is code for dy dx. And that becomes 1 over cosine squared y dy equals cosine x dx.
Who's right? Sin x.
Yeah, that's what I meant. Okay, this looks mystifying until you realize that 1 over cosine is secant. So now that we know it's secant squared y, we can recall that secant squared is actually the derivative of tangent. So when I integrate now, the integral of secant squared is tangent. The integral of sine is negative cosine x. You only need one constant on the right. Since we're solving for y, we need to inverse tangent the left side and inverse tangent the right side. I like the way we did this in period 6. We did inverse tangent of the left side. We're done. Equals the inverse tangent of the right side. You have to inverse tangent the entire thing, not just part of it, not just the cosine. As you can see, we're inverse tangent the entire right side, inverse tangent of the entire left side. Okay. So the inverse tangent of the tangent of y is just y. Let's make that black. That is just y. And then this is just the inverse tangent. Now I like to kind of switch the order here just to keep the positive term in front, even though c may or may not be positive. Let's see if we still, okay, good. All right, and that should be the answer. Cake. Cake. The instant a cake is removed from an oven, the temperature is 380 degrees. So that tells me T initial is 380 degrees. That's a really hot cake.
It's a hot cake.
I think that's a burning cake. I don't know what kind of cake would not be burned by now.
Maybe a hot cake? Or maybe a cake on fire?
Okay, after 10 minutes, the cake's temperature is 250, so T10 equals 250. That's still a really hot cake. Room temperature is 75 degrees. I keep waffling between TS and TA. They are really the same thing. Let's keep TS for now. Okay, so that should be all the information I need to solve this. Let's start with the Newton's law of equation. T minus TS equals a quantity of T naught minus TS e to the kt. Okay. And let's plug in the variables first. TS is 75. That's going to be 380 minus 75 e to the kt. K is still unknown. So t minus 75 equals 305 e to the kt. And then now let's solve for k. Or solve for k. Solve for k. 250 minus 75 equals 305 e to the 10k. That's 175 is equal to 305 e to the 10k. Let's divide that. 175 over 305 equals e to the 10k. Let's take a natural log. Natural log of, let's see, 175. We can divide these by 5, right?
Yes.
175 divided by 5 is 35. 305 divided by 5 is 61. That's equal to 10k. And so k is equal to 1/10 the natural log of 35 over 61. I think I'm going to need that number, so I'll calculate that right now. So we have 1/10 natural log of 35 over, it was 61, right? 35 over 61, yeah. Oh, you know what? Let's clear that. Sorry. I should be smart about this. Let's store that as k. Negative 0.0555. Okay, so that gives me everything I need to know. How much longer will it take the cake to cool to 90 degrees Fahrenheit? Well, when will it be at 90 degrees Fahrenheit? When will 90 minus 75, when will that be equal to 305 e to the kt, where k is known yet t is unknown? Excuse me 1 second. Okay, 90 minus 75 is 20 minus 5, so 15. 15 equals 305 e to the kt. 15 over 305 equals e to the kt. Natural log of 15 over 305 equals kt. Therefore, t will be equal to 1 over k, natural log of 15 over 305. Great. Okay, calculator time. We already have k stored, so we can just say 1 over k natural log and I forgot what it was, 15 over 305?
Yes.
Yeah.
15 over 305. 54.223. And I think these are minutes.
Yeah.
Are we rounding it all?
Yeah.
Round to the nearest 5 minutes. Okay, so the cake will be at 90 degrees after 55 minutes. So if you remember, we started at 10 minutes. Okay, so this will be in 45 more minutes. Just kind of writing it in a way that if I misunderstood the way the question's phrased, I'll have answered it exactly. You know what I'm trying to say? Like, make sure I didn't misinterpret the way the question's being asked. I'll answer it in my way, and I'll answer it in a way that I think they're asking it. Okay. Question 4. Okay, question 4, we have this equation, y equals y naught e to the negative 0.16 t. And I think the part A is what is the half-life of the equation.
Yeah.
So I think there, remember that k is equal to 1 over lambda natural log of 2 negative. So that means negative 0.16 equals negative 1 over lambda log 2, or lambda is 1 over 0.16 times the natural log of 2. Let's calculate that. Oh, you know what I was going to do? I was going to screenshot. It's part of my plan here. Start taking screenshots. That's funny. Screenshot. Screenshot. Paste. Why? I don't understand. What's going on? Screenshots. Copy. No, this one. Copy the screenshot. Paste. Yahtzee. Okay. Let's move on to the next one. Let's do the exact same thing. We've got 1 over 0.16. 1 over 0.16 natural log of 2. Let's store that as k. No, that's not k, that's lambda. What am I doing? That's my half-life. Half-life is 4.332. And And then, of course, maybe write a little something something. Okay, the half-life is 4.332 years. I think we're in years, right?
Yeah.
I think we're in years. Yeah, we're in years. So how long will it take for the sample to decay to 66% of its original amount? How much of it is left? 66% or 34%? What does it say?
66% is left. It decays to
60%. Yeah, it's decaying to 66. So we have 66% of the element is left. And that's what we're saying. So that means 0.66 of my original is still remaining. That's a really good question to ask. How much of the element is left? Make sure you don't misinterpret. Okay, 0.66 then is equal to e to the kt. Natural log of 0.66 equals kt. And t is equal to 1 over k times the natural log of 0.66. Wait, they told me what k was, right? It's negative. It's 0.16?
Yeah.
Negative 0.16, which is equal to negative 1 over 0.16 log of 0.66. T is equal to, let's do that, negative 1 over 0.16 natural log of 0.66. That looks like in 2 years. Screenshot. Copy. 2.596. $2.5969. See you tomorrow.
Bye, Bernard. Bye.
Okay. So the element will decay to 66% of its original volume after 2.596 or 2.597 years. Cool. Questions? Okay, we did 5 in class, right? Oh, we didn't do that in period 4. Darn it. Best laid plans. Question 5. Newton's law of cooling, T naught is 190. TS is 72. T of 12 is 120. I think the first thing is, what's the value of K? Okay. T minus TS equals T naught minus TS e to the KT. Okay. So T minus 72 equals 190 minus 72. e to the kt. Let's put in a number there. Let's put in 12. So 120 minus 72 equals 118 e to the 12k. 12 minus 7 is 5. 50 minus 2 is 48. So 48 equals 118 e to the 12k. 48 over 118 equals e to the 12k. 12k is equal to the natural log of 48 over 118. K is equal to 1/12 the natural log of 48 over 118. K is equal to ooh, did I screenshot the previous problem? Yeah, I did. Is equal to 1/12 the natural log of 48 over 118. And oops, let's store that as k. Okay, so k equals negative 0.0749. Great, and I have that stored in my calculator already, so I'm ready to use that for part B. What is the temperature at 25 minutes? So temperature minus 72 equals 118 e to the 25k. And that's ready to solve right there. That's 118 e to the 25k plus 72. That's 90.115. Does it say to round it all? Okay, so 90.115. C. At what time will T be equal to 85 degrees? 85 minus 72 equals 118 e to the kt. Then solve it. It's 8 plus 5, right? 13. Remember, k is known, t is not. 13 over 118 equals e to the kt. Bless you. Kt is a natural log of 13 over 118. Or t is equal to 1 over k, natural log of 13 over 118. One over k, natural log 13 over 118. Why did my calculator stop? That's not good. Ooh, look at that, it's frozen. Ooh.
Let's just say t is equal.
Let's reopen it. No. Wow, it's a bigger problem than I thought it was. TI Smart View. Die. No, what did this do? TI Smart View. Die.
This has to be very quickly.
Did it save? No, of course not. What was the first calculation? First calculation was K, 1/12.
1/12 natural log of 48 divided by 118.
1/12 log 48 over 118. We're storing that as K, right?
Yeah, 48.
Is that right?
Yeah.
Okay. And what was the second one?
It was t minus 72 equals 180 25 t to the 25 t.
118 e to the 25k.
T. Oh yeah, k, sorry.
K plus 72.
Plus 72.
And the last one is 1 over k
Natural log.
natural log of.
13 over 118.
Thank you.
100.
13 over 118. Sweet. Screenshot. Great. 29426. Okay, so t equals 29.426. And screenshot. Good. Next question. 6, non-calculator, part. Give me 1 second. I actually have to take care of something. Sorry.
We just said, looks like we're just staring into like, we are number 6. Would you like to see number 6? We are number 6. Good for you. Why does it look like we were just staring into influences? Oh, delete everything. What did you find the integral of the partial?
I have the partial difference.
Find the integral of that?
Partial fraction decomposition.
What is the natural log of those partial fractions?
I don't remember what this is.
Wait, what'd you get for the partial
5 sevenths over t minus 5 minus 5 sevenths over t plus
T positive 2?
exactly the answer. Actually, how I got it?
No, all you have to do is find
What?
all you have to do is find 16. Which would be the natural log. So
First
the
part, you just have to separate them.
Spanish for bye-bye. Wait, what'd you get for the partial decomposition? 5 what? 5 over what? 5 seconds.
What does it even mean?
You're a mean person. Note this down on Mr. Ferrer's video thingy that Justin
I
will
can
try to
do
help
this
him,
time.
he shushes them.
Honestly, I would say I'm not telling you to do this.
See, how do you like this? Yeah, how do you like this?
Go all the way down, Michelle.
Michelle, let's get on the list.
Michelle?
7, 6, 7.
Okay, where are we?
Number 6A.
6A, we need to do a partial fraction decomposition, which I love saying. 5 over, can we factor that? Minus 5 plus 2? Is equal to A over x minus 5 plus b over x plus 2, which is equal to x plus 2a. Why is that a 2 and not a 5? Plus x minus 5b okay, now we choose our values. X equals 5. We have 5 equals 7a plus 0b. A equals 5 sevenths. X equals negative 2. We have 5 equals 0a minus 7b. So b is equal to negative 5 sevenths. So our partial fraction decomposition. 5 over x squared minus 3x minus 10 is equal to 5 sevenths x minus 5 minus 5 sevenths x plus 2. Remember, this is the only time when I'm going to say it's okay to leave that compound fraction. That's part A. Part B. Part B. Find the antiderivative of C. Okay. Antiderivative of 5 over x squared minus 3x minus 10 dx is equal to the antiderivative of 5 sevenths over x minus 5 minus 5 sevenths over x plus 2 dx. This antiderivative is 5 sevenths the log of x minus 5 minus this antiderivative is 5 sevenths the log of x plus 2 constant. So we got 5 sevenths the natural log of x minus 5 over x plus 2 plus constant. Part C, average value, is equal to integral of, or 1 over b minus a, integral from a to b of f of x dx. Remember that from a couple of chapters ago?
Mr. What does it say? It says A what?
Average, AVG. That was on A, V, G. So in our case, we want 1 over 1 minus 0 antiderivative from 0 to 1 of 5 over x squared minus 3x minus 10 dx. Well, that's not a big deal. We already know what the antiderivative is. The antiderivative is 5/7 the natural log of x minus 5 over x plus 2. And we just need to substitute 0 and 1 and subtract. Let's plug in 1. That's 5/7 the natural log of the absolute value of 1 minus 5 is negative 4. 1 plus 2 is 3. Minus 5/7 the natural log of 0 minus 5 is negative 5. 0 plus 2 is 2. That's great. Sorry, my phone's dying. Ugh. Did I tell you that my Nexus tablet came in, my Nexus 7?
Is it good? What is that?
I'm enjoying it.
How's this?
I don't know what I'm going to do with it. I think it'd be great for reading. What am
Yeah, that's what the next one.
No, I was going to say reading manga.
Oh, never mind that.
Yeah, of course. Okay, so let's see. We can factor out a 5/7 from both of these, right?
Right.
5/7 natural log of 4/3 minus natural log of 5/2, which is 5/7 natural log of 4/3 over 5/2, which is 5/7 the natural log of 8 over 15. Ooh, that's not what I meant. That was pretty cool, though. That looks like it says August. All that work. Ugh. Average. There we go. Great. 6, 7?
You leave it like that?
Yeah. 7. Partial fraction decomposition. 1 minus x over 2x squared plus x. Okay, this is nice. The degree of the denominator is smaller, so I don't have to do any synthetic division. I probably should factor so 1 minus x, that's going to be x times 2x plus 1. It's going to be a over x plus b over 2x plus 1. So 1 minus x equals 2x plus 1 times a plus x times b. Picking convenient values, x equals 0. So you have 1 minus 0 equals a, 1a plus 0b. So a equals 1. The other convenient value is negative 1/2. I know there's nothing convenient about negative 1/2 at all. It's negative and a fraction. 1 minus negative 1/2, is that 3/2? 3/2 is equal to 0a minus 1/2 b. Looks like b is negative 3. So my partial fraction decomposition, 1 minus x over 2x squared plus x, that's going to be equal to 1 over x minus 3 over 2x plus 1. Hey, look, another partial fraction decomposition question. Eight. Evaluate 2. Oh, they factored for me. Lucky us. X plus 2 and 2 minus x. Let's get our decomposition first. 2 over x plus 2, 2 minus x is equal to a over 2 plus x plus b over 2 minus x. I forgot to explicitly tell you to check that the degree of the numerator is smaller, but we all know it is, right?
Yeah.
Thought I heard that. Serial killer gets stay of execution over issue of lethal injection drugs.
Lovely.
Well, on that cheery note, 2 is equal to 2 minus xa plus 2, ooh, that's not a plus, plus x b. Pick your values. I'm going to start with negative 2. 2 is equal to 4a plus 0b. So a is 1/2. When x equals 2, then 2 is equal to 0a plus 4b, making b also 1/2. Dum-de-dum. Back to the problem. Antiderivative of 2 over x plus 2 to minus x dx, that's equal to the antiderivative of 1/2 over 2 plus x plus 1/2 over 2 minus x dx. I think I'm going to do this the old school way with the u substitution. So let's say u1 equals 2 plus x. So du1 is equal to dx. u2 is equal to 2 minus x. So du2 is equal to negative dx. Okay, so what do we got here? This turns into, this was the dotted line box, right? Look at that straight line. Alright, so that's 1/2 integral of du1 over u1 minus 1/2 du2 over u2 so that's equal to 1/2 natural log of u1 minus natural log of u2 which is equal to 1/2 the natural log of u1 over u2. What did I just write? Ooh, plus constant. Okay, and I'm going to apply that square root now. Natural log of the square root of u1 over u2. Remember, even-powered roots are handy here because they make the absolute value go away. The range of an absolute value function is of a square root function is always positive. So this is equal to, so the antiderivative of 2 over x plus 2 minus x dx is equal to the natural log of the square root of u1, which is 2 plus x plus 2, over 2 minus x plus constant, bada bing. What room?
See, my room, which is the same key as hers. Or 3. There we go. Gracias.
That was Melvin.
Yeah. I'm going to stop this, and if we have any questions, we'll go for them now, okay?